All right, I'm just playing around with op amps again, and this is the LM358. It's the same op amp that I experimented with before. This time I'm using a Digilent product. The software we're looking at here is an oscilloscope representation in waveform software from Digilent. I've got a non-inverting op amp set up here, fed with supply voltage from the Digilent Electronics Explorer board. And it's feeding a arbitrary waveform that it's sweeping through a frequency range, and that's what we're looking at here. The input signal is in blue, and then the output signal from that LM358 is shown in yellow. As the frequency increases, you can see that the amplitude of the output is greatly reduced. There's an amplification factor of about 60 when it gets started, and then by the end it's like 1-to-1. The other thing to note here, and I'll stop it, you can see that there's some distortion in the wave here as it crosses the zero amplitude line, and also there's a phase shift. The output is lagging behind the input, so that's not going to be good for something like an audio application. And the frequencies that I'm sweeping through here are from, let's see, we can look at the wave generation. I'm going from 1 kilohertz all the way up to 50 kilohertz in 10 seconds. So that's what's happening as we're looking at this. It's sweeping through those frequencies. You can see that the response in terms of amplification is greatly reduced as it gets up in the frequency, and then the phase shift just keeps getting more and more pronounced as the frequency increases. So one of the things I wanted to do is switch the op amp to a op amp that's designed for audio, and that's the LM833. So I'm going to swap that out here. Turn this off. I'll take that one out and swap in the LM833, which is an audio op amp. There we go. Turn it back on, and then we'll sweep through the frequencies again. So here you can see that the amplitude is maintained throughout the whole frequency range, all the way up to 50 kilohertz. And the other thing to note, as it sweeps through it again, you don't see the phase shift, or if there's any phase shift, it's much smaller. So that's much better for an audio application. So it's kind of interesting how different op amps are designed for different applications. All right, that's it. Thanks for watching.